Cool. Right. So, I'm going to end the day not talking about. Oh no, I was going to say I've got no AI content in this talk. That I've just realized is not true. There it is. AI. Okay. I'm going to talk about what we as humans, natural intelligence, are able to produce. Ultimately, software developers, people involved in IT, are the creators of the most accidental installation art on the planet. Our failure screens are everywhere. So, my name is Kevlin Henney. You can find me in all kinds of places, including airports. My name is associated with failure, which is a strange relationship. And I used to just take pictures of screens and screenshots of things crashing, and then I kind of show them to a few people, sometimes slip them into my talks. And then people started sending me them. And then we hit social media era, and people started @ing me, and then retweeting, and I started retweeting. And this moment in 2016, arriving in Bologna, I saw a Kevlin Henney screen forever attach my name directly to this. And it kind of got out of hand from there. Not too sure if I'm time traveling, but pretty sure there is no -1 a.m. or -1 p.m. And this has kind of been going on. Does this count as a Kevlin Henney? I mean, we play games with money, right? And it recently got to a point where I finally decided, because I keep getting asked, Kevlin, why do people keep sending you these screens? Why do they keep calling these screens Kevlin? So I finally got round to doing it. Spoiler warning, recent events. I will cover that in this talk. You just need to look at the date, July this year. What happened in July this year? But it has got to the point that somebody, Hadi Hariri, actually put this onto Urban Dictionary, which offers a certain amount of cool. So Urban Dictionary is what I normally use to understand what my kids are talking about, but apparently I'm there as well. So we need to talk about failure. Failure is a noun. It's also got AI in it, as I only just realized when I got on stage. And I trawled the dictionaries. I found some definitions. The fact of failing. Okay, that's fine. It's just just another way of talking about failure. It's got the word fail in it. Let's be more specific. The omission of expected or required action. Something is not happening that should be. But we start getting a bit closer to what we normally think of as failure. This is certainly failure, but we normally tend to think of that as the action of ceasing to function or the state of not functioning. Okay, that's beginning to sound familiar. Particularly this one, an abrupt cessation of normal functioning. Oops, it stopped, it broke. Now, there's also something else. Let's talk about the title of this talk, Learning from Failure. Let's talk about learning. People often say you can learn from failure. Well, no, actually, people make a mistake here. Ironically, they fail to learn from this. People say you learn from failure. That's not true. You can sometimes learn from failure. There are certain conditions under which this can happen, but we mostly ignore them. We're actually surprisingly bad at learning from failure. So let's make an effort to do this. So what do we mean by learning? Knowledge or skills acquired through experience or study or by being taught. Oh, wow. Yeah, software developers run the planet. We have plenty of experience. The action of receiving instruction or acquiring knowledge. Every time something crashes, you are receiving knowledge. Do you feel educated? The real thing, though, the best definition, the one that's most related to this talk, is this one. Modification of a behavioral tendency by experience. In other words, we don't simply passively receive, we change what we do. And this is actually surprisingly hard, particularly when we are immersed in this. So, I'm going to quote a Becky Chambers book. Becky Chambers, wonderful author. Her stuff is just brilliant. And there was this book that was published in 2019, To Be Taught If Fortunate. The quote is actually taken from the Voyager golden discs. What are these? Two probes were launched by NASA in 1977 on a grand voyage to the outer solar system. And successfully, between them, visited Jupiter, Saturn, Uranus, and Neptune. Just like an amazing piece of orbital mechanics, beautiful coincidence. And it contained a disk with messages from Earth, including this one from Kurt Waldheim, Secretary General of the UN at the time. I send greetings on behalf of the people of our planet. We step out of our solar system into the universe seeking only peace and friendship. Yeah, please don't look too closely at Earth, because it's not quite as obvious. To teach if we are called upon, to be taught if we are fortunate. That is the context of this. It's not guaranteed that we will be taught whenever we do things, whenever we experience any of these failures. So let's learn a few things. Let's start off with quantum lock. I didn't know who quantum lock were until a couple of things were tweeted and then put onto a shared Signal group earlier, I think it was in August. And this is their page. The Quantum Lock is a game from Fat Bomb Studios. It was created in 2015. Fat Bomb Studios are based in New Mexico. And the real focus here is Quantum Lock, shutting down purchases. Hey, everyone. Quantum Lock was our first game, and although it was a big milestone for us, it was created at a time before we understood version control software. And this is a story that continues being told. In fact, in the opening keynote, Michael actually mentioned, there's a lot of people who don't use version control software. So let's be really clear about this. Now, I edited this book a few years ago. There's a lovely piece of advice in 97 Things Every Programmer Should Know from Diomedes Spinellis. I'll just put the title. You can read the rest at your leisure. The title tells you everything. Put everything under version control. And this is an interesting point, because he's not simply saying put your source code. That's your config, your scripts, all the things you don't think of as being part of your project. Your binaries. I remember having this big discussion with somebody a few years ago. They said, that's easy, we can just regenerate those. No, you can't. You have no guarantee you will ever be able to regenerate exactly the same thing. Okay? Do not trust other people, especially if they sell you compilers and things like that, because they are software developers as well. Oh yeah, that's why I don't trust them. Brilliant. The only thing you trust is the thing you built. That's the thing that's out in the field. You may be able to generate something that's almost identical. It may even be identical, but you do not control that. That is outside your control. If you take a copy of it, you control it. Simple as that. So, to be taught if fortunate, what are the lessons? In addition to that idea of understanding version control, I'm also going to throw in an extra one. Because we shouldn't assume that everybody automatically knows about version control. Why would you? You have to have been taught specifically. But I'm also going to add in an extra one. Take backups. That's not the same as version control. But a lot of people say, our source code, it's there. It's on GitHub. Oh, okay, what happens if something happens there? Backup means we take a copy on a separate physical entity. Now we're beginning to control things. Okay, this is about risk and risk management. Staying with the games industry, I want to pick on EA games. Who's heard of EA games? Yeah, they're kind of big, right? So this one crossed my radar earlier this year. We are aware of an issue on console in which the game may crash on startup. Oh, that's not good. That's definitely not good. This is currently being investigated and will be fixed as soon as possible. When did they tweet this? 29th of February. You know what's coming. Guidance for PlayStation players. On your console, go to Settings, Set Manually, change the date to March the 1st, 2024. So, EA games, console games, I'm going to guess that most of their stuff's written in C and C++. Here is the function. that they wrote. Is a year a leap year? There you go. That's the code they wrote. It's really easy to write this one. Actually, this is the problem. This is the code they wrote. They weren't aware of it. And there's a couple of things I'm going to come back to with that. But the second thing is that when we do this stuff, we have a habit of assuming that things are simple. If you ask most people, they will assume this is how you determine whether or not a year is a leap year. Guess what? Most people are wrong. This is how you determine whether or not a year is a leap year in a Gregorian conformant calendar. It's a little more complex. Most people do not know how to work out whether a year is a leap year or not. And when I say most people, that's not just the general population you find on the street. I mean most developers. I've been asking this question for decades. And you're lucky if 5 to 10% of the people who are asked know. And this is really important, although it seems like a very trivial thing. Because this isn't even the hard bit of date time handling. Oh my goodness, if you actually want to know the full answer for any given geographical locale, I am not going to show it to you because I respect you as a human being and I do not want you to throw up. The code is frightening. So in this book, 97 Things Every Java Programmer Should Know, that Trisha G and I edited, I wrote a piece on dates, and one of the things I pointed out, the most obvious lesson is that date time handling is harder than people expect, even when they're expecting it. If you think you understand date time handling, you are probably wrong. I will put money on it, large amounts of money. If you think you don't understand it, you are probably right. There are always edge cases. It's a frightening head-on collision between human rationality, astronomy, history, and politics. So what are the lessons here? There are a number of lessons here. First of all, honestly, rely on your programming language. Your programming language has stuff. It's not going to be perfect. But if you think you can do a better job, you're probably wrong. Rely on your library. Again, it's not perfect. Rely on the standard libraries. If you're going to write a piece of code that does something better, then I have one suggestion for you. Make sure it's better. Not in your head, but in reality. What does that involve? Oh, that involves testing. That involves understanding the domain, which goes right back to this idea that whatever you thought is simple is probably not. Every domain is more complex than you initially appreciate. So when you take a step in there, understand the boundaries of that. Make sure that they are fully tested. Make sure that they are cross-reviewed. And test in terms of your dependencies. Date and time are external dependencies. This is really important. They are like resources. Use it that way. So let's get bigger. Let's talk about systems. The making of a fly. What is the making of a fly? The making of a fly is a book. It's a book on genetics. The genetics of animal design. Nothing sinister about that, apparently, and I cross-checked this with somebody. I was running a training course at a company, and there are a lot of scientists and engineers at this company, and somebody happened to have a PhD in genetics and said, yeah, this is a standard reference, so I know this for real. You can see this book is kind of second-hand. It's a scan of it. So what's so interesting about this book? Well, I'm going to take you back to 2011. And take you back to Amazon Marketplace. And this book was available at quite a price. You could buy this book for $1.7 million US. You could buy that from one of the vendors, Profnath. Or you could spend a few pennies more and buy it for $2.2 million from another vendor, Board Books. Or, my preferred option, you could buy it second-hand for $35 US. But if you want to buy it first-hand, it's going to cost you. Hang on, I mean, what documents are worth this? This must be everybody's heard of this book, right? To have such a price. What's going on? Well, this is the thing. Michael Eisen noticed this, and over a period of successive days, tracked the prices. And he realized that there was a fixed ratio. It turns out that Profnath was always at 99.8% of Board eBooks' price, consistently, every single day. Turns out that Board eBooks were consistently at 27% above Profnath's price, which tells you Profnath had the book. They also had a strategy that was encoded. A consistent strategy that sometimes is, we will undercut anybody else out there. Whatever price you can find at another vendor, we will sell you cheaper, 0.2% cheaper. What we learn is that Board eBooks did not have the book. Their strategy is, you give us this, we will go and buy the original and have a 27% markup and sell you that. And then so what is interesting is that both of these are technically and testably correct strategies. But they both suffer from a problem. They assume that they are the only agents in the system acting in a particular way. These are individually correct, and yet when combined into a system, lead to, this. This was when the plug was pulled. Such runaway behavior has since been fixed in Amazon, and you might say, well, this is a problem of the past. No, it isn't. It's an underlying, deep systemic problem that we have in all software systems. And that's the point. The word system here applies. This is a quote from Earl Wiener. Wiener's laws are used in aviation for safety-critical systems. Digital devices tune out small errors while creating opportunities for large errors. We see this all the time with flash crashes. Algorithmic trading. This is the absolute guarantee. We see this all the time because this is what happens when you have a system that has lots of individually correct agents working with one another. So this is really about architecture. This is a wonderful book on architecture. It's actually about proper architecture, not this software stuff we do. But there's a lot to learn from our point of view, and there's this wonderful quote from the Finnish architect, Elil Saarinen. Always design a thing by considering it in its next larger context. So the lessons we can learn here, in addition to knowing something about genetics now that we didn't know before, the lessons we learn here are the understanding that, yes, individual correctness is important, but we also need to understand the level of the system. We need to throw ridiculous scenarios. We need to integration test. We need to monitor at runtime. We need to always take the lessons of the past and go, yeah, what happens if you do this in a system? We must assume that we are not the only people doing a particular thing. But I want to bring humans back into this. Knight Capital. Oh, fantastic story, this one. I'm going to take you back to July 2012. July the 31st. On the 1st of August, the New York Stock Exchange is going to do a few things that are a little bit different. Everybody who trades and has software that interacts with New York Stock Exchange knows this and has known this for months. There's a switchover date. Because on the 1st of August, things are going to go differently. How differently? Well, let's focus on this company, Knight Capital. Knight Capital Group, which doesn't really exist anymore. You'll understand why. Because on the 1st of August, things did go differently for them. Knight Capital Group realized a $460 million US dollar loss in 45 minutes. That's $10 million per minute. I wish I had that kind of power. And importantly, let's clarify, humans can't make mistakes this fast. Okay? If you want to screw things up at speed, you absolutely need a computer. Yeah, we just can't, I can't lose this kind of money at this speed. But actually, this is not the full story. Because it turns out that they lost billions, absolutely billions, in incorrect trades that arose from a bug. 460 million is the resulting loss after they were all rolled back. They actually lost far more per minute than I just said. This is after they rolled as many of the transactions back as were possible. New York Stock Exchange has kind of a rule, basically, if trades are made in error, genuine error, they can be rolled back. But the overall cost of this left them a little bit out of pocket because they only had 360 million in the bank. So they were down 100 million. What happened? What happened here? There's a lot going on here. So I'll take a couple of things from Doug Seven's DevOps blog. Some really nice observations and some insight here. The update to SMARS, that's the system that caused this, was intended to replace old, unused code. This is your first warning. Referred to as PowerPeg, functionality that Knight hadn't used in 8 years. This code is dead, very dead. The code that was updated repurposed an old flag. I'm not going to lay the blame with the folks at Knight Capital. I have done this. I have repurposed old flags and old fields and things like that. You do it because it's just like, well, nobody's actually using that, so, the alternative would be to change a protocol that everybody relies on, or a record that nobody uses that. Just be aware that you are making an assumption, especially when you say it out loud. When you say it to your colleagues, they need to hear it and note it down. Because assumptions are things that can be proven. You need to really know that. Now, this is the interesting thing, that Doug Seven's taking it from a DevOps perspective, and he says, why code that had been dead for 8 years was still present in the code base is a mystery. Oh, no, it isn't, not if you're a developer. But that's not the point. No, he's completely wrong. It totally is the point. It is absolutely the point. When you end up with low probability events that cause devastating outcomes, it is absolutely to do with all the small details. Because the point is, these things do not happen because of one thing. They do not happen because of the other thing. They happen because of one thing and the other thing. That's the cause of many of these things. The point is, they don't happen simply for a single reason. It is the intersection of that. Because had they not had the dead code, they'd have just had a faulty installation. Yeah? If they had a correct installation and had the dead code, it would have been fine. It's the intersection of the two. When two low probability events come together, they have a baby that is worth hundreds of millions of dollars. So I have this observation. Deleting dead code is not a technical problem. It is a problem of mindset and culture. It is not a technical problem. You can just delete it. But how will we know if somebody's using it? Well, you will find out. Or you've got one way of finding out, or you've got another way of finding out. I leave that one to you. It's kind of trivial. And if you're really not sure, then that tells you something about your own process. That's what you have to fix. It turns out it's not a code problem, it's a people problem. It's a problem of mindset and culture. These things are huge warning signs. They tell us what we're missing. That's what we can learn from this. The report from the Securities and Exchange Commission highlights the detailed problem. During the deployment of the new code, however, one of Knight's technicians did not copy the new code to one of the 8 SMARS computer servers. So they did the deployment manually. Okay. Knight did not have a second technician review this deployment. Oh, they did it manually on their own. Brilliant. They didn't review. So there's quite a lot that we can learn from this. If you go on a flight, listen to some of the activities in the preparation of the flight before they depart. There is normally a message from the flight attendants. There is normally a message from the cockpit. The captain will say something like, "Crew, arm the doors and cross-check," or words to that effect. What does that mean? It means that those doors that you just walked through, you don't really want those opening at altitude. You want them to stay very, very closed. These are points of potential failure in an aircraft. What they do is they lock them, and then they cross-check. They have the other flight attendant go and check their work. If you are going to do something manually, we already know how to do this. Get another pair of eyes. Software development is normally done in teams. IT departments are multiple people. They are rarely an individual. Take advantage of the other humans around you. But also, look at something and say, is this something that we should potentially automate? Because the more you automate it, the better you become at it. But also, if you're going to do the automation, please test that and get another pair of eyes to go through the code. It's the same principle applies. Oh, this is a nice big bada boom. I like this one of my favorites. So, this is now retired. This is one of the most powerful and reliable launch systems in the world. European Space Agency's Ariane 5. Okay, it is one of the most reliable launch systems ever created. And this is it launching from French Guiana. And on its maiden flight, this is about 45 seconds after launch. It is now one of the most reliable launch systems on the planet, but that's not how it started. That was how it's going. This is how it started. One of the most expensive fireworks in history. Estimated cost around $400 million, and that was in 40 seconds. That's $10 million a second. Beat that, Knight Capital. Okay? This is the 4th of January, 1996. All that stuff you see, that is the cluster mission, now being spread over the forests of French Guiana. What happened? Well, one of the nice things about public agencies is that they're required to make public reports. And this is one of the first major public reports that was released on the internet. This is 1996. I remember when this was released, I went and downloaded it because nothing like this had ever been available before. This is fantastic. I mean, I'm not going to say it's the most exciting read, but let's look through this. Data at that time did not contain proper flight data. Oh, okay, so there's some data between different parts of the rocket, and somehow data that is guidance data, flight data, is not correct, but showed a diagnostic bit pattern of the computer of the SRI-2, which was interpreted as flight data. Okay, let me translate that for you. Wait a minute. There are bits that contain data that should be used for adjusting the course of the rocket. That seems reasonable. But what if they're not actually bits that contain flight data? What if they are bits that say something's not working, and you cast that and you interpret the bits that go, help me, you interpret those as numbers. In other words, you interpret basically any data as a bunch of numbers. Well, it's going to come out as garbage, at which point the rocket starts doing crazy things. So here's the thing. The reason why the active SRI-2 did not send correct attitude data was the unit had declared a failure due to a software exception. The most interesting thing about this software exception is that it was disabled because they said this can't happen. Has anybody ever heard that or said that? You don't have to confess if you've said it, but I'm sure you've heard it. It was somebody else who said it. Yeah, my friend said it. That's the one. One of the things, so there's a report, this study was done in 2014 for, it surveyed a number of distributed middleware, open source distributed middleware platforms, and looked at the failures. So first of all, one of the lessons, simple testing can prevent most critical failures. That would be a good idea. But one of the most interesting things they observed, almost all catastrophic failures are the result of incorrect handling of non-fatal errors explicitly signaled in software. In other words, a piece of code said, this doesn't work. And there was code that trapped that, except it was disabled. So this is a kind of an interesting one. All those empty catch blocks and things like that, go and look at those. It was caused during execution of a data conversion from 64-bit floating point to 16-bit signed integer value. The floating point number which was converted had a value greater than what could be represented by a 16-bit signed integer. 64-bit double, 16-bit signed. Bigger, smaller. This does not fit in here unless you're within a particular range, right? Absolutely. It turns out that this software works perfectly for Ariane 4. This is an example of reuse. If you were in Neil Ford's session earlier on, he made a point that reuse is not the good thing everybody thinks it is. There are preconditions that must be met. There are dependencies and assumptions you need to respect. You cannot just take something that works in one context and reuse it without testing in another context. That is a bad thing to do. Reuse is not always a good thing. The problem is that Ariane 5 has a much steeper flight profile. The value that overflowed, well, let's have a look at it. So you don't have to read French to be able to translate this. Un petit bug, un grand boom. Fantastic, I love it. This actually contains the source code. Okay? And if you're looking at that, wondering what on earth is that language, any guesses? Sorry? Yeah, Ada. Yeah, it's Ada. Or specifically, it's a dialect of Ada. It's called Adatran. It's not a formal dialect. It's what Ada looks like when you get Fortran programmers to use it. This is incredibly badly written Ada. It is so shockingly badly written that it is amazing it passed review, which makes me wonder if they did actually review it. I've looked at Ada code. I've consulted on an Ada book. There's some really bad stuff here, and you can't say it's to do with it's to do with flight critical. No, it isn't. So the interesting thing here, the conversions were not protected. In other words, it's an unsafe cast. There is a huge irony that had this code been written in C, because everybody talks about Ada, who's come across it, talks about it as a safe language. Had the code written in C, Ariane would have gone into orbit. Because C doesn't care if something overruns. It's just, yeah, I'm cool. That double doesn't fit into that short. Yeah, fine, whatever. We're good. It doesn't cause an error. Other conversions of comparable variables in the same place in the code. Oh, let's have a look at that code. I want you to look at that if structure. This is a thresholding. It's basically saying, hey, if that number's too big, make it not too big. If that number's too small, make it not too small. Otherwise, it's just right. So this code is all the way, this happens all over the code. But I also want to draw your attention to the code quality. Hard-coded literals. 32767, does that feel familiar? Yeah? Yeah. To the rest of the population, these are just arbitrary numbers. To software developers, you can't help but go, oh yeah, that's the maximum value of a 16-bit signed integer, minus 32768. And then what's this other stuff? That's hexadecimal. The developer got so bored that they thought, I'll hard code it in hex and in decimal within 2 lines. They can't even be consistent within 2 lines. If you just showed me this code and hadn't told me bad things happened, I would tell you, don't feel comfortable. Don't get comfortable with this. You either want it one way or the other, or, and here's a crazy suggestion, you want to program this in Ada. Because it turns out in Ada, you can say, whatever the type is, give me the maximum. Do not hard code it, ask the type system. There's no point in having a type system if you don't use it. Use the language. Ada is more than capable of dealing with this. And we have all of this. Okay, but what's all this doing? Well, they could have refactored this, because remember, it says this happens all over the code. In most languages, we call this a clamp operation. If you don't have a clamp operation, which automatically thresholds a value, in other words, you say, I've got a value, here's the maximum, here's the minimum, please make sure it lies within this range, and either put a ceiling or a floor on it. It is a trivial function to write, it's available in a lot of languages, and if it isn't, like I say, easy to write. Instead, they copy and paste, because maybe if you copy and paste it enough, that really shows you know what you're doing. Oh, and in case you're worried about efficiency, Ada also can do this. It has inline functions. And you can get rid of all the spare expressions. This is how it should look. The problem is the one place that this assumption was not tested. There was one piece of code. This is the piece of code that will not overflow because Ariane 4 will not go fast enough. It turns out that Ariane 5 does. And we could have just fixed that with a clamp operation. It's as simple as that. So there is a point here, which is that test your assumptions. Oh, by the way, there are two things that I need to tell you. One, there was software that worked. The self-destruct system worked. Yay, whoever wrote that, well done. You see, up until 1996, I thought that self-destruct systems were just things you found in, Star Trek or Alien. But no, they're for real, because obviously you've got a missile. You don't want that going out of control. You want to be able to, just blow it up. So whoever wrote that software, congratulations. But there's another thing. The most interesting thing about this story, we've already learned. This code was dead code. This code was not necessary for Ariane 5. They reused a whole load of stuff, including stuff they didn't need. The code that was running was no longer necessary. It was actually the operation had been taken over by ground control. So they had this code that, I keep using the term dead. That's wrong, isn't it? It's zombie code. It's come back to life. This is a zombie apocalypse. Please delete your dead code. Please have a proper approach to reuse. It's not enough to take a piece of code that worked in one place and casually drop it in to another. It needs to be reviewed. It needs to be tested. And then look at the intrinsic quality of the code. If you see recurring patterns, factor them out. Factor this stuff. We know about refactoring. But also, look at the basic use of the language. Are we using our language effectively? Now, here's an interesting one. It's a little bit more minor. O2 had a bit of a problem in 2018 in the UK. It was December. It was approaching Christmas. They are one of the largest telecoms providers, and suddenly they're not. This was bad. They had a huge outage. What was the cause of this outage? The cause of this outage, turns out they are running Ericsson systems. O2 outage highlights importance of software certificate audits. It was an expired certificate. Initial analysis of the problem by O2's supplier, Ericsson, said the issue occurred because of an expired certificate in the software installed at customers using a specific version of software. I know certificates are not interesting. I know that licenses are dull. I know that all these things are bureaucracy and administration that are not about the code. But they are about the software system. The boring administration needs to be done. It turns out you can bring down the best stuff with just an oversight. So, I want to look at left pad. Does anybody here remember left pad? Let me start. Yeah, this is roughly what I expected. Because somebody made an observation. Left pad happened in 2016. Somebody made an observation that the number of developers, there's a kind of every 6 months to 1 year goes past, and the majority of developers, I think it's something like 18 months, after 18 months, half the people who are currently developing software have been developing it for less than 18 months. So we have this problem of not retaining our history. Left pad caused a bit of a problem in 2016. somebody withdrew a license. It was a piece of open source software, only a few lines long, and a lot of companies didn't realize they depended on it. It was in the NPM repository. Those of you who use JavaScript will be familiar with this. It's a big old mess of stuff, and there are some terrible code in there. I accept that open source is a gift culture, and we should honor that, but you don't have to put every gift on your front shelf or in your application. Sometimes we take the gift and we smile at the person who gave the gift and we put it away, never to be seen again. So we respect the gift aspect, but we need to understand what's going on. What happened is they changed their licensing model. Somebody who disagreed with their change, and they are absolutely entitled to do that, decided to withdraw all of their libraries, over 200 libraries. The point is, your software system does not simply depend on your source code and your binaries and your build pipeline. It also depends on your licenses. And it turns out that, yeah, this is quite important. It turns out a lot of people didn't know that they depended on this because this piece of code was used by another piece of code that was used by another piece of code that was ultimately used by theirs. And that they dynamically linked this in. Please test your deployments and make sure you have a fixed version of your deployment, and also make sure you take a copy of it. Do not trust other people to hold on to code that you used to use. Okay? So, this is the code. This is the code that caused loads of websites to crash when it was removed. It's not very good code. There's another surprise in it, I'll come to in a bit. It's not very consistent JavaScript. It's also not very necessary. It's a string padding thing. If you think, so I've told you, go and reuse stuff, but be careful if you're reusing it outside your standard library. This is non-standard. NPM is mostly garbage, with all respect to all the developers who contribute to it. Do not trust anything that you pick up on the streets. It's not great code. Why would you reuse this for string padding? I remember having a discussion with a developer a while back, and they said, I don't like using the word programmer, I prefer developer. And I said, is that because most developers can't program? Because that's what it looks like. Padding a string is not the hardest problem you'll ever encounter, but dependency management may well be. Classic XKCD, modern digital infrastructure. Somebody kind of has a little piece there, and everybody depends on it. Adrian Collier made the observation that it's often not the direct dependencies of your project that bite you, but the dependencies of your dependencies, all the way down to transitive closure. If you are reusing a lot of code, do you know what you're reusing? Do you know your transitive closures? If the answer is no, I don't, it means you don't know your architecture. Most organizations do not control their architecture. It's mostly guesswork outside their own code. Oh yeah, we pull that external dependency. You need to do this. Test your dependencies. Manage your dependencies. Why? Oh yeah, and retest them when you get that back in. Because it turns out, because of the chaos, they unpublished this. Here's what didn't happen. Lots of people, when the code was unpublished, or unpublished, they just took left pad again. They did not inspect it. They just trusted it. They are very lucky that it didn't look like this. Okay? So let's be clear, this did not happen, but had it happened, that would have been an even more exciting story. Review your dependencies. I remember when I told this to somebody, they said, you mean we've got to review all the stuff we import? Yes. Well, that's a lot of work. Welcome to software development. This is actually what they replaced it with. This is even worse than the previous code. It shows such a deep I mean, again, everybody has a learning curve, and I respect that. But that doesn't mean you have to use that code. This shows such a deep misunderstanding of how JavaScript works that this should not be let out of the classroom. I also discovered, I had a go at doing this and came up with a much shorter solution, but I discovered something really interesting when I wrote my code. These are the tests. For those of you who are watching through color blindness, like I am, that's green. I just thought, oh, I will run my tests on both of the versions of left pad that were available. I discovered they did not pass the tests. They had bugs. These were not only widely used and unreviewed, they were untested. This code was not tested. It just happened that most people were using the bit that worked. They weren't using the edge cases. Do not trust stuff out there, okay? Taking on needless dependencies, Fragile Development Guide. Now, there's another piece of advice I want to give you here. This is how you would have used it. Following this episode, the ECMA standard went on to include pad start as a replacement. I have put a cross through this for a very specific reason. When something in your something that you have written or brought in through an external source becomes standard to your platform, whether that's your language or any of your other dependencies that you actually control and trust, when it becomes standard, here's the piece of work you need to do. Take out that dependency from your code. Even if you wrote stuff, if somebody else is looking after it and you trust them, it's now your job to take it out of your code. Don't say, yes, but it works. Yes, but you don't want to have to maintain it. Take it out of your control. Give it to somebody you trust. It's now part of the language. Well, it's a separate question whether you should trust JavaScript or not, but that's a different conversation and a different talk. So these are the things we learn from this. So the final one. Now, Tarek said in his talk, who's here in Tarek's talk? Well, Tarek was. And he said, oh, you know, I work for the biggest company that nobody's ever heard of. I'm going to have to say, man, that's the second biggest. This is the biggest company that until July nobody had ever heard of. CrowdStrike. Friday the 13th, because somebody said to me, oh, it's a shame it wasn't on Friday the 13th, because it was on Friday the 19th. And I said, you're not a proper developer, man. Of course it's 13, in hex. Everybody counts in hex. So, remember I said that my name is associated with failure? Yeah, this was a very busy day. Perhaps the greatest Kevlin Henney event of all time. Oh, busy day for you, I suppose. Yes, it was, especially as I was away from my computer. When I got back from my computer and my phone, it's like, oh my goodness, something has blown up. Yes, lots. Now, one of the most interesting things about the CrowdStrike episode was the CEO of CrowdStrike said, we're actively working with customers impacted. You can tell this was carefully drafted. As a native English speaker, you would never use the word impacted except as a result of a meeting and a kind of like PR process. That's not normal English. Please don't use that. In a single content update for Windows hosts, Mac and Linux are not impacted. This is not a security incident or cyber attack. Actually, I'm going to disagree. It's one of the biggest security incidents we've ever experienced. There is almost no difference between a defect and an attack vector in a widely deployed system. The only difference is in intent. One can be exploited to be the other. From the point of view of the user, the experience is roughly equivalent. We still don't know the total cost of the CrowdStrike event, but you know, many airlines are saying, oh, $500 million US for us. And that's just some of the airlines. It's a huge event. There was a summary of this, and this is in their sensor. What that software does is it has kernel privilege. It is basically, it's an impressive endpoint security solution, but it runs in the kernel. Now, hopefully this problem will eventually, in the long term, go away. There's a thing called eBPF, which allows you to run code with kernel privilege, but in a sandbox. It has to be native code because it's running with the kernel. So that's C and C++ from this point of view. Maybe Rust would have prevented this, we don't know. But the idea is that this is an off by 1. Something was looked for that was not there. 21 fields instead of the expected 20. So this is a bit of a problem. Now, here's an interesting observation. This actually came about not in their config, or rather not in their main code, but in their config. This was to do with their configuration. A paper from 2016 talks about this observation of configuration errors. It says Our study shows many of today's mature, widely used software systems are subject to latent configuration errors, LCEs, in their critically important configurations. You see, we have a blind spot. We don't consider configuration to be code. So it turns out that it kind of is. I wrote, we have the problem here that we just consider the code to be code, but it turns out if you're familiar with software, one of the oldest acronyms in this space is GIGO. Garbage in, garbage out. And that's exactly what was experienced. The data of configuration was incorrect. What this piece by Dylan Ratcliffe highlights is that actually CrowdStrike have a really good process for testing their code. But they have a different process that is not quite as thorough. It's probably more thorough than most organizations, but it's not quite as thorough for config. They treat it separately. The idea is, ultimately, we have to ask the question, what is configuration? I wrote a piece a few years back on this, or that included this. Configuration is a formal structure for specifying how some aspect of your software should run. What do we call that? We call that code. People think that JSON, that XML, that whatever, that's not code. This is my code, sitting there in the IDE. That stuff there is not real code, it's just config. I've got bad news for you. It absolutely is code. It will affect how your software runs. The final lesson from this one is that there was actually early warning from March onwards that there could be a problem here. When you have identified a critical part of your system, the next thing is you need to work out who to listen to. It turns out other parts of the company had evidence to the contrary. They knew that something could happen. They just probably didn't expect it to be as large as that event. But the idea is that the signs were already there from around March or April. And this is quite difficult for us because often in software we are surrounded and immersed in loads of feedback, which tells us we have to prioritize, but to pay attention as well. These are the lessons. So, in closing, and recognizing that I am keeping you from partying, history is a vast early warning system. We have, in software, we have a wealth of history. People often think, oh, software development is young. It's not that young. It's younger than everybody in this room. It runs the planet. Most of the examples I showed you are from the 21st century, and we're really bad at our history. Jorge Santayana observed, those who cannot remember the past are condemned to repeat it. Georg Hegel was a little more pessimistic. What experience in history teaches this? That people have never learned anything from history or acted on principles deduced from it. I hope that is going to be different for you. Thank you very much.